Hello everyone, my name is Brian Fredrickson, and today I'm going to be demonstrating a client-server socket communication through C programming. As you can see here, I have two Windows PowerShell terminals open to be able to run the programs to communicate with each other. I'm going to break this video up into two sections. The first one will be demonstrating the instant messaging feature and then the file feature. And then for the second half of the video, I'm going to be going into the code. So as you can see in both terminals, I have directed to the project directory where I have the clients.c and the server.c. So I'm going to start this by running the server application first because that's how it should be. So, and then let me start this one real quick. Client, okay. So for the left one, creation of the server socket. It's initializing all the information, such as the port we're going to use, the address scheme, and who's allowed to connect. And now it's going to go into the binding process. And it was a bind success, so it's now ready to receive client communications. So now we're going to be listening on port 8080, and 8080 is a commonly known development port for companies and for anyone that wants to experiment with sockets. And then, so now we're going to activate our client socket binding or connection process, I should say. So same thing. We're going to activate the Windows Sockets API to communicate with our NIC card. So we have this. So on the left side, we saw that there was a connection success. We're connected to the client. So now the server socket is binded to the client socket. So now we can start communication. So for the instant messaging feature, we can enter message because I broke it up into two styles. So you can do either instant messaging or a single file transfer from the server and the client. So we'll have message. So it activates messaging mode on both ends. So if we want to start communication with the client, we can go hi server from the client side. And since it is instant messaging, it should appear on the server side instantly. So we received a message from the client, hi server. So if we want to send a message back to demonstrate the two-way communication, we can say hi client, and we get a response from the client. So this, just to show you that it can work for just more than one message, I can say hi again, and we can go hello, and we get the same thing. So if we want to exit this communication, we can just type exit. This can go for both ways as well. I just want to demonstrate it on the client side, and it closes the connection between the two, and it deallocates all the memory used to initialize some of the network information for the socket API. So now I'm going to demonstrate the same thing, but for the file transfer. So on the left side, we have the client, same process as before. Listening on port 8080, we have the connection made. So let's say we want to go into file mode. Now we are both in file transfer mode. So the server socket realizes that a file transfer wants to be made, and this was done by sending a file message beforehand, so the server knows that it's going to be accepting a file. It's kind of the similar way that GET requests work to web servers. They know that they're going to be requesting web content. So now the server is ready to be prompted with a file path that we're going to send from the client. So please provide the path of the file that you would like to send. So I'm just going to go in to my local file on my client side, and I'm going to first demonstrate that you can send multiple types of files. So first we'll start off with the PNG. So let me navigate to the PNG here. And here we go. Copy as path. So just for clarity, it's going to be this one right here. So this is what we should receive on the server side. So I'm going to copy that as a path. I'm going to paste that into the file path of the local client side. I'm going to get rid of the quotes because that's how it handles it correctly. And once we send this, we should see something prompt up on the server side. before we do that, we have to specify what we want the file to be named as to be saved on the server side. So I'm going to say image, or save that as image. File transfer complete, file saved as image. So instead of just prompting on the text and say, oh, it's saved, I'm actually going to show you that it's saved on the server side. So since we're operating on the local host, the file is going to be saved in the same directory we're running the program. And right here we see image. So if we decide to open this image in Firefox or something like that, let's go Firefox. You can see that that's the same image that we sent from the local machine. And I'm going to demonstrate that it also works from the server to the client too. So let's say the server wants to send a file to the client side rather than client to server. So from the client side, we can say get. I kind of just simulated this, how a web server would work, but it still shows that you can send files from the server to the client. So if I do get, on the server side, it looks for the file path that you want to send. So on the server side, I'm going to go and show you that we can demonstrate this for just a text file. So let me copy this one as path. So it's going to be this one. So we have test. This is a test file. So it's just a short text file. It should be really easy to send. If I paste that, file sent to client. And similarly, what we did before, we have to specify how we want the file saved as on the client end. So let's just name it text file. File transfer complete, file saved as text file, and both the connection is closed. So I'm going to navigate now to my project directory. And here we have text file. So if we open this, let's open this in Firefox. This is the same file that I sent beforehand. So that was a quick demonstration of how the client server socket in C works. And we're going to go into the next part of the video showcasing the different parts of the code. So now I'm going to be going over the client.c file in the project directory. I haven't commented all the functions just to keep the video length down, but you can access my GitHub and go into the repository and you can read the other comment blocks that I'm going to be adding later. But for now, I'm just going to be going over the essential functionality of the client.c. So these are variables and structs that allow the setup of the socket API to work. So this is the startup function, which basically communicates with your NIC card. Hey, I'm going to be accessing some type of socket communication, like making file descriptors. This is the creation of the socket and also instantiating and setting values of some of the struct values. The connect function on the client side to connect to a server socket. And if the connection was successful, it goes into basically this loop that's prompting what kind of messaging that you're going to be doing. If it's a message, it goes through the while loop of sending and receiving connections from the server. And this is done. I'm trying to look for the section that allows you to do that. Yes, okay, so this is done under a while loop, so it's constantly going through a cycle of sending and receiving connections. And we have the string compare of, so message is the variable that keeps track of the current message you're sending, and it resets the buffer through every cycle. And I will show you the server side in a second to show how that communication works. But the key functions of here are the send and receive functions. Those are definitely the key aspects of the communication. And there are also error handling. So if it doesn't work, it's going to return a value and exit the socket communication. And this is the same thing except for the file type handling. So it goes into file transfer mode. It opens a file path. If one already hasn't been created or instantiated for a file, it creates one, and that allows you to save and write the binary to the new file. And I also implemented an acknowledgement message. So once the client has has been finished sending all the bytes of the file, the server sends an acknowledgement message back to the client saying, "Hey, I got your message. I got your file. I'm ready to send a file to you now." So that way, that there's no rushing and there's no overlap of things being sent or any infinite loops of both ends receiving a connection. So this is the Git implementation I was talking about, and I'm trying to find the loop where I have where it this. Okay, this is the key part. So this is the while loop that essentially, while while the while the client is still reading the file, it is sending out bytes to the server, and on the server side, it's constantly reading bytes until that there's no more bytes to be read. So I'll go over the server side. Okay, so the steps that I talked about on the client side, it's more complex on the server side because the server has to handle multiple clients. So there is a bind function. The bind function basically binds a certain server socket to a specified client socket. So the client doesn't have a bind function, but the server does. The server listens for connections, also another feature that the client does not have, and accepting connections. So this allows the client to connect to the server and start the connection. So similar process here. If the command type that I entered before, like message or file, it does a string compare to see which one or which mode we want to work in, and we go over this. If it's message mode, kind of same concept, while one, and then until an exit is typed, then it exits out of that while loop, and then it closes the socket connection. If it's a file, let me go to the section. So this is also a key part. An error that I encountered the first time was on the last read of a received file, it would stop. So for instance, for like a PNG, it would have like 324 bytes left to read, but it would go in an infinite loop of continuing to receive because it had not satisfied the buffer size, which is 1024. So it was expecting around 800 to 900 more bytes to be read. So that's why it kind of went in that cycle. So instead of this, to solve this, I kept track of a total received bytes to keep track of, okay, don't stop until all the file bytes are read, and then you're ready to go. And then these are just error messages saying that if the file was received in transit or not, and diagnostics to help to help me see what was going on in the process of it. So this is also the GET request. So this allows the feature of the server to send files to the client. Same procedure in the sending. So while loop and then send. So that's kind of how it works, and then finishes up by closing the socket. And then I'll go over one more aspect. These are the essential libraries that allow the client server to communicate with each other. If you're interested in more of the content about the client server architecture, you can find that in the GitHub the GitHub link provided. But other than that, that is pretty much the whole implementation. Overall, I'll probably add more features to it and more complex socket, features as I learn more about it. But this is kind of just a base level. So thank you for listening and have a great rest of your day.